Okay, you watched the video last night. So we're going to go through today, and we are going to discuss some things about Avogadro's number and moles and molar conversions. So let's start out by looking, and you should have got this from the video, but looking at some possible labels. Now, if we were going to group this into one huge group, we would say that representative particles would include all three of those. And once I switch over to the flux capacitor, you're going to see that, yeah, representative particles was that bottom right branch, so to speak. So, when we're discussing these, if I have a single element, that is labeled atoms. If I have a combination of elements that are covalently bonded together, we refer to those as molecules. And finally, if I have a group of elements, or in this instance, a binary compound, two elements, if I have a group of elements that are ionically bonded, we refer to those as formula units. So the three types of labels I can have on these representative particles are atoms, molecules, formula units. Okay, the latter two are depending on what? How they are bonded together. And if you remember, a couple of units ago, we talked about bonding. Okay, we talked about bonding. Is that clear with the labels? Good. Now, one of the big things on the video was this guy right here, which I call the flux capacitor. Okay, anybody ever watch Back to the Future? Anybody seen that movie? It's an older one, but it's still an older but goodie. Okay, what they had there was the thing that allowed them to travel back in time was the flux capacitor. And it had three branches, so to speak, something like this. So I just named this guy the flux capacitor. Now, you will use this thing as a visual aid. Will you be able to use this on any test that you take? No. Okay? But if you memorize it, I've seen people that have memorized it and wrote it down before they started doing the test. Okay? I don't have any problem with that. But the flux capacitor is just a visual aid to help us do these molar conversions. So, the first branch that we're dealing with is this guy right here, going from moles to representative particles. Moles to representative particles and vice versa. So, when I am doing this, we talked about in the video conversion boxes, didn't we? A conversion box. I believe I used the example of the dozen, right? In the video to show you how to do conversion boxes. Well, on our flux capacitor here, okay, I'm going to set up a conversion box for this green arrow right here. Okay, the green arrow right there is going from moles to representative particles, so I'm heading that way. What do I want to cancel is what I put on the bottom. So on my bottom of this is going to be 1 mole, and on the top is going to be Avogadro's number. So that's the 6.022 times 10 to the 23rd. Now, depending on what you're dealing with is depending on what label I use. Once again, what are my 3 different labels I could have? Atoms, molecules, formula units. Okay? So it will be one of those 3 different types. Now, if I am going the other way, the yellow arrow, and I'm going from representative particles to the mole. If I'm going from representative particles to the mole, I just use the inverse of that. So my conversion box is going to be 1 mole on the top, Avogadro's number on the bottom. That will allow me to make my cancellation in order to convert it from one to the other. Okay? Now, we're just dealing, like I said, we're just dealing with this one branch, moles to representative particles. Okay? You see up here also moles to the volume of a gas. We'll do that one later. That's the last one we will go over on the flux capacitor. And here is mole and mass. Mole and mass we will do, I believe it's sometime. I don't think we'll get to it before break. Okay, I think we'll be getting to that after break. Yeah, all right. So we will cover all of the flux capacitor piece by piece. Now, here's your very first example that we're going to work. Go ahead and copy it down. The question is, how many atoms are in 0.909 moles of silver? Now, the first thing I do, folks, is I look to see if my labels match up. Would I label silver as an atom? Yes, I would. Because you're going to see later on that there are 2 parts problems using Avogadro's number. We'll deal with that later. Right now, we're only doing 1-step problems. So I look, atoms, would I label silver as atoms? Yes, I would. So I've got the correct label. I can do a direct conversion. Now, I've been doing these things many, many years, folks. I've been doing these many, many years, and I still, when I do these, show my work. Okay? Do not become what I call a plugger. And what a plugger is it's that person that just punches buttons into the calculator and does the math on their calculator. The process that we are doing now, the process is going to be essential when we deal with stoichiometry. Stoichiometry will be in 3rd 9 weeks sometime. So the process is important to learn. And that process is using conversion boxes. If you come up and ask me, say, hey, Mr. Braun, I've got a problem on WebAssign. It isn't working out. And I say, okay, where's your work? Let me see it. And you go, well, it's right here in my calculator. I got it right there. See it? I won't even read it. Okay, because I can't read work on a calculator. I can read work on a piece of paper and look at it and say, okay, here is where you're varying off the path. This is where the problem is. I can pinpoint it. I will not look in your calculator and try to pinpoint your plugging. All right? So if you've got a question and you're coming up to ask me about it on your WebAssign, you better have what? Some work. Now, the thing about this is we can prevent mistakes. I've been doing this for 20-some years, folks, and I still make mistakes doing it. But when I show my work, I can pick them out and say, duh, right there. Okay, right there. Now, I have 0.909 moles of silver. I need to convert that into atoms. Well, I'm going to set up a conversion box. And if I go back to my flux capacitor, here, which one of these am I doing? Am I going moles here to representative particles, or am I going the other way? I'm going from moles to representative particles, so I am going to use this guy right here, correct? So, I come back to my problem. Here we go. So I have 1 mole of silver has Avogadro's number. My label is atoms of silver. When I do so, I bring her down here. I'm going to do my math in my calculator. So I take the 0.909 and I multiply that by Avogadro's number. And I come up with a value of, and here's my total value that my calculator is telling me, okay? 5.473998 times 10 to the 23rd. Now, how many significant figures do I have in my problem? Okay, we're going to get back into sig figs. If you need to review your sig fig notes, review your sig fig notes. How many significant figures do I have in the problem? 1, 2, 3. So I need 3 in my answer. So when I come up here, I have 5.47 times 10 to the 23rd. What's my label going to be? Atoms of silver, because if I look, my mole cancels, doesn't it? What's a mole over a mole? 1. So it cancels out. So I get my final label to be atoms of silver. So when I'm completed, just so Mr. Braun can find my answer, I draw a box around it. Now let's go to our next example. How many molecules are in 3.944 moles of ammonia? Now, the very first thing that I would do is I need to determine what is ammonia. If you remember way back when, we're talking probably over a month ago, I told you 3 things that you needed to memorize that were common names. One of which was water, H2O. That's pretty easy to remember for us, right? Another one was methane. Methane was good, Tyler. CH4. Okay. The third one was ammonia. And ammonia is what? NH3. Okay. So I have 3.944 moles of ammonia. I am converting, once again, I'm at moles and I'm going to representative particles. I guess I should check, does it make sense to label ammonia molecules? If I look at ammonia, what type of bonding will ammonia have? Covalent bonding. Would I label something that is covalently bonded a molecule? Yes. Okay. So once again, I check my labels. They jive, so I'm good. This is going to be a direct conversion from moles to molecules. So I put my conversion box up. I know that 1 mole of ammonia has 6.22 times 10 to the 23rd molecules of ammonia. So when I plug into my calculator, 3.944, multiply that by Avogadro's number, and looking, I have how many significant figures with this one? I have 4 sig figs here, so my answer I'm getting is 2.375 times 10 to the 24th. My moles cancel, so my label is going to be molecules of ammonia. Draw my box around it so Mr. Braun can easily find my answer. Now, a couple of things. A couple of things to be aware of. I have seen a lot of times that people miss the e to the 24th in their calculator. See how it's at the very end? Sometimes folks miss that e and they just put an answer as something like 2.375. Now, is 2.375 anywhere near that number that I have in the box up there? No. Okay? So make sure that you're aware of that you don't miss that e. I talked yesterday with Abdul because we were having some problems with the calculations. Okay? Your calculator follows order of operations. Please excuse my dear Aunt Sally. Ever heard of that? That's how old Braun was taught when he was a little guy, to remember it. Please excuse my dear Aunt Sally. What is it? Parentheses, exponents, multiplication, division, addition, subtraction. All right? Now, I'm going to pull up a blank one here to show you something. I'm going to pull up a blank slide to show you something. If I have a really big number like 2.57 times 10 to the 37th. How am I going to put that into my calculator? Okay? What some people do is they do this. 2.57, they do the multiplication button, they do 10, and they do a caret 37 as so. Now, based on your order of operations, what's going to be first here? The exponent. So the exponent's going to be first. Okay? And then it's going to multiply it by 2.57, which is okay right here. It works out perfectly fine, doesn't it? Now, let me throw in this wrinkle. Okay? This wrinkle is that I'm going to now divide it by Avogadro's number. Right? Now, when I'm following my order of operations, all right, when I'm following my order of operations, doing this like that gets it screwed up. Because we're going to multiply this, then we're going to do both of the exponents first. Okay? Then we're going to divide after we multiply. So basically, your calculator is saying, all right, let's do these exponents first. Okay? Then I'm going to multiply right here, and then I'm going to divide. And if you do this, go ahead and do this in your calculator like I have it right there with the carets. Okay? Go ahead and do that into your calculator. What did you get when you did that? What did you get when you did that math? 4.27 times 10 to the 59th. Right? Now, that is an incorrect answer. That is an incorrect answer because your calculator is following order of operations. Now, if I do it like that, if I'm going to do it like this here, folks, what do I need to do, Connor? I could put parentheses here, and it would work out fine. Because I know, and just an estimation, I know my number is going to be to the somewhere, what's 37 minus 23? 14. So it's going to be somewhere near the 14th power. So I know that. I do it like that, it works out. Now, here is the way that I do it. Because my calculator knows scientific notation if I tell it. So, I'm going to type in 2, let me get all this crud off of here. I'm going to type in this number as 2.57. Then I'm going to hit my exponential button. My button on my calculator, and I have a graphing calculator like this, is the second function of the button over the 7, which is a comma. Okay? If I hit second function of the comma, up pops a tiny little e, right? That tiny little e, I then type in 37. So my calculator is now reading that into scientific notation. Then I divide it by Avogadro's number, and I get my correct answer. So, knowing how to work your calculator is also essential here, because you could do all of the work correct and then put it into your calculator incorrectly and come up with the wrong answer. Okay? Do we understand what I'm getting at with this and your calculator? Because this is going to come into play with our very next example, because I have a scientific notation example. So go ahead and copy that down. The question is, how many moles are in 2.38 times 10 to the 26 formula units of strontium nitrate? Strontium is a 2+. Strontium is a 2+. The polyatomic nitrate is a 1-. So strontium nitrate is Sr parentheses NO3 parentheses 2. So, as I'm doing my conversion, would I label, well, it is labeled formula units, okay? So I'm trying to go to moles of strontium from formula units. So I'm going to take 2.38 times 10 to the 26 formula units of strontium nitrate. I'm going to do my conversion box. What do I want to cancel? I want formula units to cancel. So now, based on my flux capacitor here, who is not cooperating with me, based on my flux capacitor, I'm at representative particles, and I'm going to moles. So I'm going to use that right there. My Avogadro's number is on the bottom. So when I come back down here, I put 6.022 times 10 to 23rd formula units of strontium nitrate is over or under 1 mole of strontium nitrate. Now, do my labels cancel? Formula units, strontium nitrate formula units, yes they do. So now when I do my math, I'm going to take 2.38 times 10 to the 26 divided by 6.022 times 10 to the 23rd. What should my answer be exponent-wise? Okay, just a guesstimate, I take my 26 minus 23, so it should be somewhere around 3, right? When I do my math, I get the number of 395.2 217. How many sig figs? 3 sig figs. My label? Moles of strontium nitrate. Yeah. If I would put this, the question Connor has is, he's going to put that guy into scientific notation. As so, right, Connor? Same thing. Okay? Same thing. I see those two things as the same exact number when I'm grading. So, could you put it into scientific notation? Yes, you could. Sometimes you're probably going to have to based on sig figs and WebAssign. Okay? Sometimes you'll have to put that into scientific notation. Jacob? Okay, sometimes you have to. Okay? Because if I have only 2 sig figs here, okay, I could put it, but I could put it 400. But how does that say, how do I signify that second digit is significant? I can't, so I got to put it into scientific notation. I can't put a bar on WebAssign. All right? Any other questions for me?